when we are doing a significance test, we're testing whether or not the slope equals 0, and it's also a test for whether or not correlation equals 0. And if you want to just think about that for a second, the formula for correlation the formula for slope, B, is R times SY over SX, okay? And so you see that if my R is 0, what's 0 times anything? 0. So if R is 0, B equals 0. And that's why they're so linked. If one of them 0, the other one's 0. And so we're doing our null is that beta. Remember, your null is always based on a parameter, not a statistic. That's a statistic. That's a parameter. So the null is that beta equals 0. The alternative is I'm pretty confident that beta is bigger than 0. And then we're getting this probability over here. Or I'm pretty confident that there is a negative slope. Well, that's the p-value that we would get. All right. And I'm pretty confident that beta does not equal 0. And that's the sum of these two probabilities, both of them together. Okay. So it doubles the probability that you're bigger than one or less than the other. Okay. And I want to talk briefly about this. If beta is 0, if beta equals 0, then why does there seem to be a pattern that implies that there's some sort of slope there? If there's really no correlation and there's no slope, what's the probability that I would get a pattern like mine or more drastic? That's what we're dealing with when we talk about this p-value here, okay? So this is some data, 20 foot lengths and heights, okay? And this is the regression line. You can see the slope is 1.03, all right? And we're wondering, like, what's the probability that if I took these y values of heights, right? If foot length and height are really unrelated, if there's no correlation, then why is this 32 related with this 74 instead of being related with this 66 or 77 or 67 or 56? There's no rhyme or reason to why any two numbers would be paired together if there's no relationship between foot length and height. And so what we do is, when you think about a p-value, we could just shuffle all of these y values right here, okay, and see how often we get a regression line with this slope of 1.03 or steeper. So notice there's the actual slope. When I shuffled them, notice it's not as good of a pattern as that. So this is actually evidence that this is a unusually strong pattern, okay? What's the probability that we could shuffle these points and get a pattern that's at least this strong or stronger, okay? Well, let's shuffle them a few times. That one's pretty steep negative, but even then it's only a negative 0.49. It's not close to a 1.03 slope, okay? That one's almost horizontal, 0.25. That one's even closer to horizontal, 0.12 is the slope. That one's pretty flat, a little bit negative, pretty flat. A little bit negative. That one's almost perfectly flat, 0.06. Like, that's like no relationship. Look how scattered that is. When we shuffle them, a lot of times we're getting almost no relationship. Look how steep this one is, though, right? Sometimes when you shuffle them, you do get a decent pattern. Look how powerful that is, okay? Look how strong of a pattern that is. We only get a slope of 0.73, so it's not as strong of a pattern as this one, but if you keep shuffling, maybe, ooh, there's a decent negative one. Maybe we'll start to get some that are as steep as mine or steeper, right? We're getting there. Let's do a bunch at a time. And we can actually count what's the probability that we get a slope beyond 1.03, okay? Right now, I've done 34 times, and we're seeing nothing even close. Let's do 100 of them and see what happens, okay? So we shuffle 100 times. Still, notice, we're getting some that are close to the actual steepness, and maybe this one that's close on the negative side, right? We're getting close to -1, but we're still not even getting there, okay? There's still been 0 out of more than 1,000, okay? 1,300, we've had 0 slopes that are as steep as my line or steeper. Look at that, but we're getting close. We're getting close. What if we did it 1,000 times, okay? This will take a while, but 23, 34. We've had one slope. One slope. I can't tell if it's on the negative side or the positive side, but really, out of 2,334, we've had one time where shuffling these Ys has given us a relationship that's at least as strong as what the data actually showed. So do we think that there's really no relationship and the only reason why these guys lined up was because of pure shuffling luck? Well, what's the probability of pure shuffling luck that's as steep as ours or steeper? 0.0004. Very, very, very unlikely. And so I would be leaning towards the statement that really there is a relationship between foot length and height. There is a correlation. There is a slope. Okay, the slope is not 0, would be what I would conclude. Okay, so the p-value, if the null is true, that there is no linear relationship, that there is no slope, that there is no correlation, then what is the probability we would have as strong of a correlation or as steep of a slope as we got or steeper? Well, if you just randomly shuffled the Ys over and over and over again, how often do we get something as steep as my line or steeper? Okay, so that's what we're looking for here. And that's what that p-value is really measuring. Okay, what's the probability that if there's no relationship, what's the probability that we would get a slope like ours or greater, right? Because this is the slope divided by the standard error of the slope. Okay, so notice parameter is always going to be beta. Okay, is the true slope. The hypotheses will always be beta equals 0, and then the alternative will be beta is less than or not equal to or greater than 0. Okay, and this is two-tailed. These are each one-tailed. Assumptions and conditions. This is the liner that we talked about earlier. Linear, independent, normal, equal, and random. Okay, equal standard deviation. Name the test. It is a test for slope. Okay, so it is a hypothesis test for slope. It's a t-test. Okay, our test statistic, remember, is right here. Our p-value will typically be handed to you on a silver platter. And then you see, wow, really small p-value. What decision should I make? Reject the null. There is sufficient evidence to suggest that there is a relationship or a correlation between, and then you just tell me what your two variables are. Okay, so that's the kind of stuff we're going to be doing, guys. It's not bad at all, especially when you're given everything on a silver platter. If not, you can do stuff on the calculator. Interpreting things is still probably the most challenging part for these least squares regression lines. So good luck and farewell.